Assalamualaikum. Hi, we meet again with me Puan Rosmawati binti Jamaluddin. So today we still discuss the chapter of chemical equilibrium. We're going to focus on subtopic equilibrium constant. I hope that you still remember how to know whether the system at equilibrium or not. Yes, by looking at the arrow present in the chemical equation. Student, there are two types of equilibrium system. One is called homogeneous equilibrium system. What are the properties of the species until they are considered as homogeneous equilibrium system? One of the property is all reacting species must present in the same phase. Look at the example for the formation of ammonia. Look at the phase of nitrogen. Look at the phase of hydrogen and the phase of ammonia. They are present in the same phase. So, the system is called homogeneous equilibrium system. Same apply to the second example. The reactant ion are present as aqueous. So do the product ion. Both of the product ion present in the aqueous phase. So reactant in the aqueous phase and the product also in the aqueous phase. So this system is called homogeneous equilibrium system. The second type of system is called heterogeneous equilibrium system. In this system, the reacting species contain two or more phases. For example, calcium carbonate produce calcium oxide and carbon dioxide. Look at the phase of calcium carbonate. It present as solid. Look at the phase of product calcium oxide, solid also. Are they can consider as homogeneous equilibrium system? No. Look at the last product, carbon dioxide. Carbon dioxide present as gas phase. So, more than one phase present. The reaction is heterogeneous equilibrium system. The second example is neutralization reaction between ammonia and HCl. Ammonia present as a gas. HCl present as liquid, whereas ammonium chloride present as solid. There are three types of phase present in this chemical equation. So, this neutralization reaction is heterogeneous equilibrium system. All the systems at equilibrium must behave according to equilibrium law. What is stated by equilibrium law? Equilibrium law said that when a system has achieved equilibrium, the ratio of the concentration of product raised to the power of its stoichiometric coefficient to the concentration of reactant also raised to the power of stoichiometric coefficient is a constant at constant temperature. Let I show you what's the relationship between the reactant and product according to the equilibrium law. Let's consider this general equation. Reactant A with coefficient A react with reactant B with coefficient B, produce product C with its coefficient and product D with its coefficient. According to the equilibrium law, the constant of this equilibrium system can be written as K equal to the concentration of C, power of C, multiply with concentration of D, power of D, over reactant A, power of A, and reactant B, power of B. And this system is at equilibrium, right? So, the constant here is called equilibrium constant. The equilibrium constant can be expressed in terms of concentration, what we already did in the previous slide. Let's say you have this example, general equation. Same as the previous slide, right? To write the expression of equilibrium constant in terms of concentration at equilibrium, Kc equal to concentration of C multiply product D over concentration reactant A multiply concentration reactant B. Kc is called concentration equilibrium constant. To write the equilibrium constant of the chemical equation, you just concern the species that present in the aqueous and gaseous phase. If any species present in form of liquid and solid, you have to ignore them and omit them from the equilibrium expression. Instead of we express the equilibrium constant in terms of concentration, we also can express the equilibrium constant in terms of pressure. But you have to be careful when writing the expression of equilibrium constant in form of pressure. Let's say you have this equation. Looks similar, but look at the phase. For this system, the equilibrium constant is written as Kp equal to pressure of D, power of the coefficient D, over pressure of A, power of coefficient A, multiply pressure of B, power of coefficient B. You know why we ignore the presence of C in this expression? Yes, because C present as aqueous. So we omit them from the expression of equilibrium constant. Kp here is equilibrium constant in terms of pressure, whereas P is a partial pressure of the gas. I hope that you get better idea how to write the equilibrium expression in terms of Kc and Kp. But I would like to give you one example. Let's consider the dissociation of calcium hydrogen carbonate to form calcium carbonate, water and carbon dioxide. How to write the expression of Kc for this system? Remember equilibrium law? Equilibrium law says that constant is equal to the ratio of product over reactant. So the product that we are going to include in this expression is carbon dioxide only, because solid and liquid are omitted from the expression. So product is concentration carbon dioxide. There's no power shown as a superscript because the coefficient of carbon dioxide is 1. So no need to write 1 as a power. If other than 1, you have to write. For the reactant, we just consider calcium hydrogen carbonate because it present as an aqueous phase. Also, there's no power shown to the next of concentration calcium hydrogen carbonate because the coefficient for this reactant is 1. Then done for Kc expression. We move to Kp. Kp, we just consider the species present as a gas only. If you study the equation, you found that the reacting species present as a gas is carbon dioxide. So, only expression of carbon dioxide pressure is included in the Kp expression. So, Kp equal to partial pressure of carbon dioxide. To get better understanding, you must try this question. You want to know the answer? Please do a consultation with me. Good luck, student. Bye.